In a previous video, you saw how a magnetic field can exert a torque on a current loop. So we referred to that idea as the motor effect. And you also saw perhaps that a motor of this design always needs a little kickstart to get it going. The reason is when the brushes contact the commutator of this motor, eventually when it comes to rest, the brushes are sitting in the little gaps of the commutator, which normally is good while the motor's spinning because that shuts the motor off at the moments in time that the armature would be just receiving a stretching force as opposed to a twisting force. So as it spins around, the brushes sometimes contact the commutator when the torque would make it spin, and the brushes contact the gaps when there would be no torque. If it always comes to rest with the brushes in those gaps, it's the kickstart that gets it moving. All right? So this motor design needs the kickstart, this one doesn't. What would it look like if we took this motor apart? We would find a design that's more like this. Instead of a pair of conductors at the commutator and a single armature, we have three armature windings and a commutator with 1, 2, 3 gaps in it. So let's see what happens when I connect this motor to my DC power supply. It should spin a lot more effectively. Let's get the power on, connect the brushes at the commutator, and